The wind, a razor honed to a terrifying sharpness, knifed through the air at 8,000 feet in the unforgiving embrace of the Rocky Mountains. Bjorn Hogan learned the brutal lesson of that altitude during his first winter in 1881. Ice bloomed on the interior walls of his roughly hewn cabin, delicate yet menacing. Drafts, like mischievous spirits, whipped snow through the chinking, the hastily packed gaps between the logs, mocking his efforts. He had followed the gospel of the frontier, constructing his cabin precisely as every other trapper in the territory had been instructed. Saddle-notched corners, a crude interlocking system, mud and moss relentlessly stuffed into the cracks, the standard frontier method, deemed good enough by the hardscrabble settlers. By spring, Bjorn had fed his insatiable fireplace twice the firewood of his neighbors, yet still battled the persistent, bone-chilling drafts that snaked through his walls. He spent back-breaking hours huddled near the fire, dreaming of warmth. Within 3 years, he found himself engaged in the Sisyphean task of rechinking the gaps every season, a ritual of defeat shared by everyone else in the valley. Up and down the high country, trappers were losing the same exasperating battle against the inexorable shrinking of green logs and the inevitable crumbling of their haphazard chinking. Cabins, built by the book, seemed doomed to perpetual disrepair. Then, Bjorn Hagen, a quiet, observant man, subtly applied a traditional corner treatment passed down through generations in his Norwegian homeland, a method whispered to possess secrets to defy the elements. The change was remarkable. What profound understanding of log joinery did he possess, allowing his cabin to remain sealed tight for half a century, defying the harsh mountain winters without a single repair. The saddle notch method held dominion over frontier cabin construction, and for understandable reasons. A trapper, often alone and facing the relentless pressure of time, could carve the rudimentary half-moon cuts in each log end within minutes, using only the single-bladed axe he carried everywhere. It was a quick, pragmatic solution, creating a basic interlocking joint that held the logs in rough alignment, a framework upon which to build. Most settlers then frantically packed the unavoidable gaps with whatever materials they could scavenge, clay laboriously mixed with prairie grass, moss stripped bare from the silent trees of the forest, or mud dobbied thick and clumsy between the log courses. The technique demanded no specialized tools beyond what every frontiersman already possessed, no precise measuring, no esoteric knowledge passed down through generations of master craftsmen. Speed was paramount, eclipsing perfection when the specter of winter loomed large and essential supplies dwindled. Across the valley, Bjorn Hagen quietly observed his neighbors dutifully follow this exact pattern through the waning days of autumn in 1881. Tom Morrison, a grizzled trapper hardened by years in the Missouri wilderness, notched and stacked his cabin walls with astonishing speed in just 4 days, boasting loudly that he would be out trapping beaver while others still fussed and fretted over their buildings. The Hendricks family, newly arrived from Kansas, diligently packed their gaps with a mixture of tenacious local clay and sun-baked dried grass, completing their chinking in 2 long, exhausting afternoons. Even the more methodical builders, men like Jacob Steiner, rarely took more than a week to complete their walls, understanding that they needed to dedicate as much time to hunting and gathering vital winter supplies before the heavy snows descended and trapped them in the mountains. But by the following spring, the hidden costs of this frontier efficiency began to manifest themselves, revealing the flaws inherent in their haste. Morrison's cabin, so quickly erected, developed a persistent, icy draft along the north wall, where his logs had settled unevenly, creating gaps that no amount of additional chinking could permanently seal. He spent hours cursing and patching, but the wind continued to whistle through. The Hendricks family endured 3 days in March redaubing their walls after the relentless cycle of freeze and thaw cracked their clay mixture, leaving finger-width openings that howled with the mountain wind. Steiner discovered, to his dismay, that his carefully applied moss chinking had dried and shrunk over the winter, pulling away from the logs and creating gaps that he had to stuff with fresh material every few weeks, a seemingly endless task. The problem lay much deeper than mere maintenance. The green logs, cut fresh from the forest and stacked immediately, continued their agonizing process of shrinking and settling for months after construction. The saddle notches, carved to fit snugly at first, gradually loosened as the wood dried and compressed under the immense weight of the upper courses. What began as tight joints slowly morphed into loose connections, held together mainly by the fickle force of gravity and the desperate hope that the whole thing wouldn't collapse. Chinking that had seemed to seal perfectly in the autumn cracked and crumbled out as the logs shifted position, leaving openings that grew larger and more menacing with each passing seasonal cycle. Bjorn Hagen arrived in the territory bearing knowledge that distinguished him from his fellow trappers, a legacy whispered in the rustling leaves of his homeland. Born in the heart of the timber country near Bergen, Norway, he had spent his formative years watching his father and uncles meticulously build homes using techniques refined over centuries of brutal Scandinavian winters, homes that stood as testaments to the resilience of both wood and craftsmanship. Norwegian log construction, known as loft in the Old Language, demanded that each log be individually fitted to the one below, using painstaking scribing and meticulous hand-carving. The process demanded patience, skill, and tools beyond a simple axe, but it produced joints so exquisitely tight that chinking became entirely unnecessary. His father had taught him the art of using a marking compass, a deceptively simple tool consisting of two metal points connected by an adjustable hinge. One point meticulously traced the complex contour of the lower log, while the other marked an exact matching curve on the log above. When carved with precision to follow this scribed line, the upper log would rest in flawless contact with its neighbor, creating a compression joint that actually tightened as the wood dried and settled, a marvel of engineering understood and respected by generations. The method consumed far longer than saddle notching, sometimes requiring hours to fit a single log properly. But Norwegian homes built this way had stood for generations, enduring the ravages of time and weather without gaps or drafts, their stories etched into the very fibers of the wood. The other trappers in the valley watched Hagen's methodical approach with a mixture of skepticism and burgeoning curiosity that quickly turned to open mockery. Morrison stopped by one October afternoon to find Hagen painstakingly scribing the curve of his seventh log course, a process that had already consumed the better part of 2 long days. "You planning to carve furniture or build a cabin, Hagen?" Morrison asked, his voice dripping with sarcasm as he spat a stream of tobacco juice into the dirt. "Time you spent on that fancy notching, I could have chinked 3 cabins and been halfway to my trap lines." The Hendricks brothers shared Morrison's opinion, though they phrased their assessment with a slightly more diplomatic veneer. "Mr. Higgins got the right idea about being thorough," the elder brother told his wife, speaking just loudly enough for Hagen to overhear. "But a man can overthink a simple shelter. These mountains don't care how pretty your joints look when the snow starts flying." Even Steiner, despite his own meticulous attention to detail, questioned the Norwegian's approach. "I admire careful work," he told Hagen during a brief visit. "But winter won't wait for perfect corners. Sometimes, good enough has to be good enough." The general consensus among the valley's trappers was that Hagen was squandering precious time on unnecessary refinements that served no practical purpose. Hagen understood their criticism, but he had witnessed too many carelessly chinked cabins fail in Norway's demanding climate to place his trust in such haphazard methods in the unforgiving Rockies. Norwegian winters brought sustained periods of bone-chilling cold that could shatter poorly sealed joints, creating drafts so intense that they rendered cabins uninhabitable, despite their thick walls. American frontier construction might work adequately for temporary shelters, providing a modicum of protection from the elements. But Hagen intended to build a home that would serve him for decades, a bastion against the harsh wilderness, not merely a structure that would survive a single season. The conflict represented far more than a mere difference in building techniques. It reflected a fundamental divergence in worldviews. Frontier culture prized speed, adaptability, and the ability to make do with available resources. Traditional craftsmanship, on the other hand, demanded time, precision, and unwavering respect for proven methods. Most American settlers viewed their first cabins as temporary structures, meant to be improved upon or replaced entirely as circumstances allowed. Hagen approached his construction as a permanent investment, a long-term commitment that would either succeed completely or fail expensively. As autumn surrendered to winter, the philosophical divide transformed into stark practical reality. While his neighbors triumphantly finished their cabins and enthusiastically began their trap lines, Hagen continued his meticulous process, scribing and carving each log with unwavering dedication to achieve perfect contact with its neighbors. The method consumed weeks rather than days, but it produced corners with no visible gaps, even before the application of chinking. Whether this traditional Norwegian approach would prove superior to the accepted frontier wisdom remained to be tested by the brutal mountain winter looming ahead. The emerging conflict would not be settled by opinions or traditions, but by cold, hard measurable results: warmth, fuel consumption, maintenance requirements, and long-term durability. Both methods would face the same unforgiving conditions, but only one would prove truly worthy of the mountain environment's relentless demands. Most frontier cabins began with the simplest possible foundation: logs laid directly on the cleared ground. The method required no additional materials, no specialized knowledge, and no extra time beyond leveling the site with an axe and shovel. Trappers and settlers simply felled trees of roughly equal diameter, squared the building area by pacing off dimensions, and commenced stacking walls immediately on the forest floor. The approach worked adequately for temporary shelters, but it harbored serious, inherent flaws that would reveal themselves with the patient passage of time. As seasons transitioned and ground conditions shifted, the unaddressed problems would gradually undermine the structural integrity of the hastily built cabins. Hagen, drawing upon his childhood observations in Norway's perpetually damp climate, immediately recognized the inherent foundation problem. His father had built their family home on a foundation of flat fieldstone piers that lifted the sill logs a crucial 8 inches above grade, safeguarding the wood from ground moisture and providing essential drainage during the inevitable spring snowmelt. Norwegian builders understood, through centuries of accumulated wisdom, that direct soil contact invited rot, insidious insect damage, and uneven settling that could slowly but surely distort an entire structure over time. The mountain valleys of Colorado presented similar, if not identical, challenges: heavy winter snow, raging spring runoff, and relentless freeze-thaw cycles that could saturate the soil and shift poorly supported foundations, leading to catastrophic results. While his neighbors rushed headlong to begin wall construction, Hagen dedicated 5 days to preparing his foundation with meticulous care. He selected 12 flat sandstone slabs from a nearby outcrop, each measuring roughly 18 inches square and 4 inches thick. The stones had weathered naturally into relatively level surfaces that required minimal shaping with a hammer and chisel. He meticulously arranged these foundation stones in 3 parallel rows beneath where his sill logs would rest, spacing them at 4-foot intervals to distribute the cabin's immense weight evenly across the building footprint. The foundation layout adhered to the principles his uncle had taught him during a barn raising near Bergen, principles honed over generations of experience. Load-bearing stones must sit perfectly level with each other to prevent differential settling, and they must extend beyond the log width to provide a stable bearing surface. Hagen employed a water level, a simple yet ingenious device made from leather tubing filled with water, to ensure that all 12 stones sat at exactly the same height. When the water in both ends of the tubing showed equal levels, he knew that the stones were perfectly aligned, eliminating any tendency for the cabin to tilt or sag unevenly, a potential catastrophe averted through careful planning and execution. Log selection proved equally critical to long-term stability. Most trappers simply utilized whatever trees grew closest to their building site, accepting knots, curves, and variations in diameter as unavoidable characteristics of wilderness construction. Hagen, however, embarked on a meticulous search, walking the valley for 2 weeks, marking only those pines that met his exacting standards: straight grain with minimal taper, a diameter between 12 and 14 inches measured 6 feet from the butt end, and complete freedom from large knots that could create weak points or drying cracks. He rejected nearly 3 trees for every one he selected. Twisted grain, Even the slightest spiraling that most builders would carelessly ignore could cause a log to warp severely as it dried, potentially breaking the tight joints he intended to create. Excessive taper meant that logs would not stack evenly, creating gaps that would widen relentlessly over time. Large knots weakened the wood and often dried at different rates than the surrounding timber, causing splits that could compromise the structural integrity of the entire cabin. Norwegian log builders had developed these stringent selection criteria over centuries of experience with timber that must perform reliably for generations. The felling and preparation process reflected an equal level of unwavering attention to wood quality. Hagen felled his trees during late autumn, when sap flow had slowed to a trickle, reducing the overall moisture content and minimizing future shrinkage. He limbed each tree immediately to prevent bark beetles from boring into the wood, their destructive appetites a constant threat. Then, he peeled the bark completely to expose any hidden defects before transport. Trees with insect damage, hidden rot, or internal checking went directly into his firewood pile rather than becoming part of his cherished wall logs. Each log received careful preparation before its placement. Hagen used a draw knife to smooth rough spots and removed protruding knot stubs that could prevent tight stacking. He meticulously checked every log for straightness using a taut string line, rejecting any piece that deviated more than half an inch over its 15-foot length. The most critical step involved orienting each log properly. The natural crown, or slight upward curve, present in most trees, had to face upward to counteract the downward deflection that would occur under the immense load from the upper courses, a subtle but crucial consideration. The first winter starkly exposed the fundamental differences between the two foundation approaches. Morrison's cabin, built directly on grade, encountered immediate problems when the relentless autumn rains saturated the soil beneath his sill logs. The wood greedily absorbed moisture through direct ground contact, causing the lower courses to swell ominously and then compress as the winter cold froze the saturated timber. By February, his cabin had settled nearly 2 inches on the south side, where runoff from the roof had created persistently wet conditions. The Hendricks family faced similar settling problems, further complicated by their careless choice of foundation logs with excessive taper. Their building slowly tilted precariously as the smaller ends of their sill logs compressed more than the larger ends, creating a noticeable slope that made their door difficult to close properly, a constant, irritating reminder of their hasty construction. The uneven settling opened gaping holes in their chinking and created stress points in their wall logs that eventually led to splitting, a slow but inexorable process of disintegration. Steiner had laid his cabin on reasonably level ground with well-matched logs, but direct soil contact still caused him significant problems. The spring snow melt in 1882 created standing water around his foundation for nearly 3 weeks, soaking the bottom logs and creating ideal conditions for wood-rotting fungi to flourish. By summer, he could push his knife blade easily into the softened wood, and he began desperately planning to replace his entire bottom course before the next winter arrived, a daunting and unwelcome task. Hagen's stone pier foundation completely avoided these problems. The raised sills allowed unimpeded air circulation beneath the cabin, preventing moisture accumulation and maintaining dry conditions around the precious wood. Spring runoff flowed freely under the building without contacting the logs. The stone piers provided stable, non-compressible support that could not settle or shift with changing ground conditions. The careful log selection ensured that his courses remained straight and true as the wood seasoned, maintaining the precise fits he had carved between each piece, a testament to the power of planning and execution. The foundation strategy proved its worth through measurable results. After 18 months, surveys using a simple plumb line showed that Hagen's cabin remained perfectly level, while his neighbors' buildings had developed noticeable tilts ranging from 1 to 3 inches over their 12-foot widths, a visible testament to the superiority of his methods. The raised foundation had demanded extra time and effort during construction, but it had eliminated the settling problems that plagued ground-level cabins throughout their short service lives. More importantly, the stable foundation preserved the integrity of Hagen's carefully crafted corner joints, allowing his compression-fit notching system to function precisely as designed, rather than loosening due to structural movement, a slow but certain form of destruction. The marking compass represented the essential difference between Norwegian and American log construction, a philosophical chasm manifested in a simple tool. This instrument, consisting of two sharp metal points connected by an adjustable brass hinge, allowed the user to maintain a consistent distance while one point traced an irregular surface and the other marked a corresponding line. American saddle notch builders had no use for such precision, relying instead on eyeballing rough cuts that would be filled with chinking anyway. Hagen's compass, inherited from his father's toolbox, enabled him to create joints that matched the exact contours of each log rather than settling for approximate fits. The scribing process began with positioning each new log in its intended final location at the top of the wall. Hagen used wooden skids and rope tackle to roll the heavy logs into place, then secured them with temporary wooden wedges to prevent shifting during the marking process. With a log held firmly in position, he adjusted his compass to span the widest gap between the new log and the one beneath it, typically measuring between 2 and 3 inches for logs of slightly different diameters. Walking the length of the log, Hagen held one compass point firmly against the lower log surface, while the upper point traced a corresponding line on the log above. The technique required steady hands and unwavering attention, as any variation in compass width or deviation from the lower log's contour would create imperfect fits. Norwegian craftsmen called this process scribing the log to the bed, meaning that each piece was individually fitted to match its specific resting place rather than cut to some theoretical standard dimension, a profound shift in perspective. The carved notch extended far beyond the simple corner treatments most Americans knew. While saddle notches created contact at just 2 small points where the upper log rested on curved shoulders, Hagen's full scribe method produced contact along the entire length where the logs met. His draw knife and curved adze removed wood in thin shavings, following the scribed line to create a concave surface that matched the convex curve of the log beneath. The process consumed hours per log but resulted in joints where nearly every square inch of adjacent wood surfaces touched. Critical to the system's success was carving the notch slightly tighter than the scribed line indicated. Hagen deliberately removed less wood than his compass mark suggested, creating a notch perhaps 1/8 of an inch smaller than the log it would receive. This forced him to drive each log into place using a wooden maul and blocking, compressing the wood fibers and creating mechanical pressure at the joint. The technique demanded judgment born of experience. Too loose, and gaps would appear as the wood dried. Too tight, and the logs might split under the pressure needed to seat them properly. The compression principle worked because wood behaves as a slightly elastic material when subjected to moderate pressure. The tight fit deformed both logs slightly at their contact surfaces, creating continuous pressure that held the joint together and sealed against air infiltration. As the wood seasoned and shrank over subsequent months, this compression actually increased rather than loosened, tightening the seal progressively over time. Hagen's corner treatment differed fundamentally from his neighbor's approaches in the geometry of load transfer. Saddle notches concentrated all the weight of upper logs onto 2 narrow bearing points, creating high stress that gradually crushed the wood fibers and allowed settling. Full scribe joints distributed the same loads across much larger contact areas, reducing stress and preventing the compression that caused saddle-notched corners to loosen over time. The tool requirements extended beyond the compass to include specialized Norwegian woodworking implements rarely seen on the American frontier. His curved adze, forged with a blade bent at precisely 20 degrees, allowed him to hollow out the concave notch surfaces efficiently while maintaining control over the cutting depth. A set of wooden-handled carving gouges enabled fine-tuning of the fit, removing small amounts of wood where the scribe marks indicated high spots that prevented perfect contact. During the second winter, the performance differences between the joinery methods became unmistakable. Morrison visited Hagen's cabin during a February blizzard and found the interior remarkably free of drafts, despite wind that rattled his own poorly sealed walls. Testing with a candle flame, Morrison could detect no air movement at Hagen's corners, even when the wind gusted to what he estimated at 40 miles per hour outside. The same test at his own cabin revealed multiple locations where the flame flickered violently, indicating significant air infiltration through loosened chinking and settling joints. The Hendricks brothers faced even worse sealing problems, as their cabin's foundation settling created stress that pulled their corner joints apart. Gaps wide enough to admit a finger appeared at several corners by spring, requiring extensive rechinking that lasted only until the next settling cycle loosened the repairs. Their fuel consumption increased dramatically as heated air escaped through the widening cracks faster than their fireplace could replace it, a losing battle against the relentless cold. Steiner's more carefully built cabin performed better than his neighbors, but still required annual maintenance to address settling and shrinkage gaps. His detailed records showed that he spent approximately 12 days each year rechinking various joints, consuming nearly half a quart of clay and moss in the process. The work became increasingly difficult as settling created irregular gap patterns that resisted permanent sealing. Hagen's cabin required no chinking maintenance whatsoever. The compression joints remained tight through 3 complete seasonal cycles, showing no visible gaps even when inspected with a strong lamp light from inside during windstorms. The wood-to-wood contact created by his full scribe technique provided inherent sealing that actually improved with age, as the compressed fibers adapted to their new positions. By the 3rd spring, neighboring trappers began sheepishly requesting demonstrations of Hagen's technique. Several watched him scribe and fit logs for a small addition to his cabin, noting how the process consumed far more time than their familiar methods, but produced joints of remarkable precision. Few possessed the specialized tools or had developed the hand skills needed to replicate his results, but most acknowledged the clear superiority of his approach for permanent construction. The economic implications extended beyond initial construction time to long-term maintenance costs. Hagen's higher labor investment during building eliminated the recurring expenses his neighbors faced for chinking materials and annual repair work. Over 5 years, his neighbors collectively spent more than 60 days on maintenance that Hagen's cabin never required, while also consuming substantial quantities of clay, moss, and other sealing materials that must be gathered and processed each season. The full scribe technique had proven its worth through measurable performance advantages that grew more pronounced with each passing year, firmly establishing compression-fit joinery as demonstrably superior to saddle-notch construction for permanent frontier housing. Green timber presented challenges that most frontier builders blithely ignored until problems appeared months or even years after construction. Freshly cut pine contained roughly 40 to 50% moisture by weight, water that would gradually evaporate over the following seasons regardless of construction method. As this moisture escaped, the logs shrank both in diameter and length, with the greatest dimensional change occurring perpendicular to the grain direction. Norwegian builders had long recognized this inevitable process and developed techniques to harness shrinkage rather than fight it. Hagen's father had taught him to monitor wood movement through what Norwegian craftsmen called the settling year, the 12-month period when most dimensional change occurred in newly constructed log buildings. The process required periodic inspection and selective adjustments to maintain structural integrity as individual logs found their final dimensions. American frontier builders typically ignored settling completely, allowing cabins to distort naturally and then addressing the resulting problems with additional chinking or crude repairs, a reactive approach that often proved inadequate. The key insight involved predicting shrinkage patterns and pre-compensating for them during initial construction, a proactive strategy that yielded far superior results. Pine logs typically lost 6 to 8% of their diameter during the first year of drying, with most change occurring during the warm months when evaporation rates peaked. Hagen carved his compression joints anticipating this shrinkage, making notches that would become even tighter as the wood dried rather than loosening like conventional joints that started with barely adequate fits. Seasonal inspection began each spring when warming temperatures accelerated moisture loss from the cabin's logs. Hagen walked the perimeter of his building with a thin-bladed knife, probing joints for any signs of loosening or gap formation. The technique required intimate knowledge of how each individual log had been positioned, as settling rarely occurred uniformly across an entire wall. Logs with more initial moisture content, higher positions in the wall, or exposure to prevailing winds dried at different rates and required individual attention. During the second spring after construction, Hagen discovered that one log on his south wall had developed a hairline crack along its upper surface, where differential drying had created internal stress. Rather than accepting this defect as inevitable, he removed the affected log completely, replaced it with a backup piece from his construction surplus, and rescribed the joint to maintain perfect contact. The repair consumed 2 days of labor, but prevented a weakness that could have compromised the wall's integrity for decades, a testament to his unwavering commitment to quality. The monitoring process revealed patterns invisible to casual observation. Logs on the south and west walls, exposed to maximum solar heating, dried faster than those on the north side, where snow lingered longer and temperatures remained cooler. Upper courses, with better ventilation and less weight compression, showed more shrinkage than lower logs that were compressed by the load of the courses above them. End-grain surfaces at door and window openings lost moisture more rapidly than the sealed log sides, creating potential stress points that required attention. Hagen developed a systematic approach to managing these variations. Each autumn, before winter cold slowed the drying process, he inspected every joint and made minor adjustments where needed. Some logs required gentle tapping downward to close small gaps that had opened during the summer drying season. Others needed slight repositioning to relieve stress concentrations that could lead to splitting. The work rarely consumed more than 2 days annually, but prevented the cumulative distortions that plagued neighboring cabins. Species selection proved equally important for long-term stability. The valley's forest offered several conifer options, but Hagen chose exclusively lodgepole pine for its moderate shrinkage characteristics and predictable drying behavior. Engelmann spruce, while abundant, tended to warp more severely during seasoning. Douglas fir. Despite its inherent strength, the wood exhibited shrinkage rates that could potentially overstress the tightly fitted joints, pushing them beyond their design capacity. Lodgepole pine emerged as the ideal choice, striking a delicate equilibrium between ease of working, dimensional stability, and ready availability, making it perfectly suited for the demands of precision log construction. The wood's grain orientation within each log played a crucial role, significantly impacting its shrinkage patterns during the drying process. Hagen meticulously positioned each log, paying close attention to its individual growth characteristics. He consistently placed the original tree's crown side upward, capitalizing on the natural curve to counteract any potential sagging under the relentless force of gravity and structural load. Even more critically, he skillfully oriented the logs to ensure that any tendency to warp or twist during the drying phase would work in harmony with, rather than against, the building's structural integrity and design. Logs that exhibited the potential for cracking or checking during seasoning were strategically placed in locations where such imperfections would not compromise the overall integrity of the interlocking joints. By the 5th year after the cabin's completion, the logs had gradually reached equilibrium moisture content with the surrounding mountain environment, effectively signaling the end of the active settling period. Precise measurements taken with calipers revealed that individual logs had decreased in diameter by approximately 1 to 1.5 inches, falling precisely within the range Hagen had meticulously anticipated when carving the original joints. The compression fit notches elegantly accommodated this shrinkage by becoming progressively tighter, maintaining complete and unwavering contact as the wood underwent its dimensional stabilization. The long-term performance of Hagen's cabin stood in stark contrast to the conventional wisdom surrounding log construction durability. Morrison's cabin, already displaying significant signs of deterioration due to uncontrolled settling and pervasive moisture infiltration, necessitated extensive repairs, including the replacement of several rotted lower courses. The Hendricks family, disheartened by their experience, had completely abandoned their original cabin, opting to build a new structure utilizing conventional frame construction after their log building became uninhabitable due to the accumulation of settling damage and chronic air leakage problems. Steiner, on the other hand, diligently maintained his cabin through persistent efforts, but his meticulously kept records documented the ever-increasing costs associated with battling the natural movement of the wood, rather than accommodating it in the initial design and construction. By the 5th year, he had already replaced 4 logs that had split due to uncontrolled drying stress, rechinked his walls a staggering 7 times, and devoted 36 days to various repairs necessary to keep the building weathertight. His annual maintenance requirements continued to escalate over time, as initial problems triggered a cascading effect of damage that demanded progressively more extensive fixes. Hagen's approach, in contrast, yielded strikingly different results. After 5 complete seasonal cycles, his cabin required absolutely no structural repairs and exhibited no signs of the deterioration plaguing its neighboring structures. The logs had settled into their final positions with remarkable precision, resulting in joints that remained entirely gap-free, even during the most severe weather conditions. Careful inspection with a bright lamp on windy nights revealed no air infiltration points whatsoever, while temperature measurements indicated minimal heat loss compared to conventional chinking-dependent construction methods. The Norwegian method's success lay not in attempting to prevent the natural behavior of the wood, but in thoroughly understanding and accommodating it through superior initial construction techniques and a commitment to systematic maintenance. By anticipating shrinkage, meticulously monitoring seasonal changes, and making small corrections before problems had the chance to escalate, Hagen had created a building that actually improved with age, rather than deteriorating like conventional frontier construction. The economic implications of Hagen's approach became readily apparent when neighboring trappers meticulously calculated their cumulative maintenance costs and compared them to Hagen's minimal annual inspection time. This comparison firmly established compression-fit construction not merely as superior craftsmanship, but as a sound, long-term investment in permanent frontier housing. The winter of 1932 brought weather conditions that tested the structural integrity of every building in the valley beyond its normal limits. Snow accumulated to depths exceeding 8 feet by January, creating loads that stressed roof systems and wall joints far beyond typical seasonal pressures. February ushered in alternating cycles of warming and hard freezing, which caused building materials to expand and contract in ways that exposed every hidden weakness in aging construction. March unleashed unprecedented rainfall on top of the existing snowpack, leading to runoff volumes that saturated soils and flooded basements throughout the region. The thermal cycling that occurred during this extreme weather sequence laid bare fundamental differences between construction methods that had remained concealed during milder seasons. Rapid temperature swings, ranging from 20 degrees below zero to 40 degrees above, sometimes occurring within 24-hour periods, caused dramatic expansion and contraction in building materials. Chinked log cabins faced particular stress, as their mixed materials, wood, clay, moss, and stone, expanded and contracted at different rates, generating shear forces that tore apart previously stable joints. Morrison's cabin, now 51 years old, suffered catastrophic failure during the March thaw. The combined weight of heavy snow loading and saturated foundation soils caused his entire north wall to lean outward by nearly 6 inches, opening gaps at the corners wide enough to throw a cat through. Meltwater poured through the compromised joints, thoroughly soaking his interior and ruining stored supplies. By April, the building was uninhabitable, forcing Morrison to construct emergency shelter from salvaged materials while planning for complete reconstruction. The Steiner family cabin vividly demonstrated how accumulated maintenance problems could compound under extreme stress. Decades of rechinking had resulted in a patchwork of different materials with varying expansion coefficients. Clay patches contracted more than wood during cold snaps, while moss insulation compressed differently than mud daubing when saturated. The thermal cycling opened new gaps faster than repairs could be made, creating a feedback loop where each temperature swing worsened existing problems and generated additional failure points. Measurement techniques available by the 1930s allowed for the precise documentation of structural performance, providing insights that earlier generations could only estimate. A surveyor working for the County Road Department utilized a transit and measuring chain to meticulously document foundation movements and wall deflections in the valley's older buildings. His records revealed settlement and tilting that ranged from 3 inches to more than a foot in cabins built with conventional methods, with the majority of movement occurring during the extreme weather cycles of that winter. Hagen's cabin, now past its 50th birthday, demonstrated measurable superiority in every category. The surveyor's examination revealed foundation settlement measuring less than half an inch over 5 decades, compared to 8 to 12 inches for neighboring structures built the same year. Wall plumpness deviated less than 1 inch from vertical, while conventional cabins exhibited lean angles of up to 4 degrees from true. Most significantly, joint integrity remained intact throughout the structure, with no detectable air infiltration even when tested with smoke sticks during high wind conditions. The thermal performance advantage became quantifiable through fuel consumption measurements that several families began tracking during the harsh winter. Hagen's nephew, visiting from Denver, diligently recorded daily wood consumption and interior temperatures using a reliable thermometer and meticulous log-keeping methods. Despite the cabin's age, it maintained comfortable interior temperatures of 65 to 70 degrees Fahrenheit while consuming only 2 1/4 cords of firewood throughout the entire winter season. Neighboring families with conventional construction burned between 4 and 6 cords during the same period while achieving interior temperatures 10 to 15 degrees lower than Hagen's cabin. The difference reflected not just air sealing, but thermal mass effects from the tightly fitted log walls, which absorbed heat during the day and released it slowly at night, moderating temperature swings that plagued poorly sealed buildings. Heat loss calculations indicated that draft infiltration in chinked cabins wasted approximately 60% of generated heat energy. Documentation of the Norwegian method began attracting attention from building professionals in Denver and Colorado Springs, who were developing mountain resort properties for wealthy clients. A timber contractor named James Sullivan visited the valley specifically to examine Hagen's construction techniques after hearing reports about the cabin's exceptional durability. Sullivan spent 3 days meticulously measuring joint details, photographing construction features, and interviewing local residents about long-term performance comparisons. Sullivan's visit marked the beginning of formal knowledge transfer from immigrant craft traditions to professional construction practice. He documented Hagen's scribing and compression fit techniques, creating detailed drawings and written specifications that he later utilized for high-end lodge construction in mountain resort areas. The precision joinery methods, previously dismissed as unnecessary refinement, gained recognition as cost-effective approaches for permanent mountain construction, where maintenance access was difficult and heating costs were significant concerns. Younger builders in the valley began seeking instruction in the Norwegian methods during the summer of 1933. 2 homesteaders planning new cabins asked Hagen to demonstrate proper scribing techniques and supervise their corner construction. Both men possessed basic carpentry skills, but lacked experience with the specialized tools and precise fitting required for compression joints. Hagen spent several weeks teaching them proper compass use, drawknife techniques, and the critical judgment needed to achieve tight fits without splitting logs during assembly. The knowledge transfer process revealed how traditional craft skills depended on subtle techniques that could not be learned from written descriptions alone. Hand coordination for maintaining consistent compass pressure while scribing, recognition of wood grain patterns that indicated splitting tendencies, and development of the precise touch needed for final fitting required extended practice under experienced supervision. Written manuals could document procedures, but master craftsmen were essential for transmitting the tacit knowledge that made complex techniques reliable in field conditions. By 1935, 4 new cabins in the valley incorporated full-scribe Norwegian joinery methods with varying degrees of success. The builders who had received direct instruction from Hagen achieved results approaching his standards, while those attempting to work from written descriptions alone struggled with joint consistency and long-term performance. The experience demonstrated that traditional craft knowledge required human transmission chains to survive transitions between generations and geographic locations. Documentation efforts expanded when the Civilian Conservation Corps began surveying historic construction techniques as part of their national forest building programs. Government architects recognized that traditional methods often provided superior performance for backcountry construction where modern materials and maintenance were impractical. Hagen's cabin became a case study in their technical manuals, with detailed drawings and performance specifications that influenced federal building standards for remote forestry facilities. The legacy extended beyond individual buildings to influence entire regional construction practices. By 1940, mountain builders throughout Colorado had adopted modified versions of Norwegian scribing techniques, though few achieved the precision of traditional craftsmen. The methods became known as Scandinavian joinery in construction circles, acknowledging their immigrant origins while adapting them to American materials and building codes. 50 years after its construction, Hagen's cabin stood as proof that superior craftsmanship could triumph over expedient methods, establishing traditional knowledge as valuable engineering information rather than obsolete folklore.